Hello everyone. In this video, we will see model evaluation. First, how to perform model evaluation using Python. So in the first starting lines, we have imported some libraries. These are the necessary libraries like random forest classifier, train test split, and metrics from sklearn, and plotting libraries matplotlib and cborn are important. The arrays dataset is loaded. Now we will load the arrays data set using the load arrays function and divided into features x and y labels. Now split data into training and test set. The dataset is splitted into training and testing sets using train test split. 70% of data is used for training and 30% of data is used for testing. Now model training. Train a random forest model. A random forest classifier is instantiated with 100 trees and maximum depth of 3 for each tree. The model is then trained on the training data using the fit function. Make predictions. Now predict function will be used after training to make the predictions on the test data. Now evaluation of a metrics. The accuracy, precision, recall and F1 score are calculated for the module using the accuracy score function, precision score function, recall score function and F1 score functions. These metrics are weighted for multi-class classification to consider the imbalanced data. Now we will print all accuracy, precision, recall and F1 score value. Now confusion metrics. The confusion metric is computed using a confusion metric function to visualize how well the model is classifying each class. It shows how many samples from each class are correctly predicted and how many are misclassified. And then we will print the confusion metrics. Classification report. The classification report function provides a detailed report of precision, recall, F1 score for each class. It helps you understand the performance of the model for each specific class. Since the dataset is a multi-class problem, the code simplifies it by converting the problem into the binary classification. This is done by using this function that using this is done using this function to transform the true labels and predictions. The ROC score calculates the area under the curve for the binary classification, which measures the overall ability to the model to distinguish between classes. The ROC curve is plotted using the matplotlib. Now we will plot the ROC curve using the matplotlib to show the trade-off between the true positive rate and the false positive rate as false positive rate as a x-axis and true positive rate as a y-axis, and then we will give the title to the curve as a receiver operating characteristics curve and use a plt.show function to display the curve. Now confusion matrix heat map. A heat map of the confusion matrix is plotted using the cborn's heat map to visually inspect the classification of performance. The labels of the rows and columns are correspond to the array's species name. And then we will use the plt.show to display the confusion matrix heat map. So when we run this following code, then first the confusion matrix will be printed like this. This output means that 13 samples from each class were correctly predicted and one sample from class 2 was misclassified as class 1. This is the classification report showing precision, recall, F1 score and support. This is the ROC curve, means receiver operating characteristic curve, and this is the confusion matrix heat map. Now moving on to the second, accounting for unequal error cost using Python. The necessary libraries are imported such as random forest classifier, train test split, load arrays and classification report. Then we will load the arrays data set. The arrays dataset is loaded using a load arrays function. This dataset contains the 150 samples from 3 species of arrays flower and 4 features of each sample: sepal length, sepal width, petal length, and petal width. Now here X represents the feature set and Y represents the label. Split the data into the training and testing sets. The data set is split into the training and test set using a train test split with 70% for training and 30% for testing. The random state is set to 42 for ensuring consistent result. Now here class 0 has weight 1, class 1 has higher weight of 5, meaning that misclassifying this class is penalized more heavily, and class 2 has a weight of 2, meaning misclassification are penalized more than class 0 but less than class 1. Now create and train the model with the class weights. A random forest classifier is created with 100 trees, a maximum depth of 3 for each tree, and specified class weight dictionary. After training, we will make a prediction. The model makes a prediction on the test set using this predict function. Evaluation of the model, we will print the text classification report, and then the classification report function is called and the precision recall F1 score and support are printed. The precision gives the proportion of a positive predictions that are correct. Recall, it gives the proportion of actual positives that are correctly identified. And F1 score, the harmonic mean of a precision and recall. And support, the number of true instance for each class. So this was the output of this code. And this was all about the model evaluation. I hope this is clear to you. Thank you for watching.